Okay, this augmented matrix right here could have come from a system of 3 equations and 3 unknowns like this. Of course, the variables could have been x, y, and z instead of x sub 1, x sub 2, and x sub 3. But the idea, you want to use Gauss-Jordan elimination to end up with all ones along this diagonal and zeros everywhere else, and then you'll have the values of the variables. So what's happening here, I like this notation a little bit better. We're going to take row 2, we're going to multiply row 1 by -2 and combine it with row 2, and the result goes to row 2. So here, you'll learn to do this mentally, but if you want to write it out on scrap paper, here's the original row 2. Here's -2 times row 1, and we're going to add the corresponding elements and put the result in row 2. That's what this is right here. And for this operation right here, we're going to take the current row 3, which is -4, 2, 6, -2. We're going to multiply row 2 by 2 and corresponding elements, and the result goes in row 3, and that's what this is right here. Now for part C, you have to use the new values. So we're going to take the existing row 3, which is now this one. We're going to multiply row 2 by 2 and add the corresponding elements. I'm going to leave that to you. I hope you got the idea. But here's where we're headed. If we keep doing these row transformations, you can divide any row by a non-zero constant, and you'll still have an equivalent matrix. The idea is to end up with ones along this diagonal, and that tells you that x sub 1 is -15, x sub 2 is -22, and x sub 3 is -3. And here they did the check for you. Okay, so your problem is just preparing you to do a complete Gaussian-Jordan elimination. There you go. Hope that gave you some idea what's going on. If you have any questions, post a comment, and I will post a URL to the website that allows you to do this. Okay.